Welcome to Organic Chemistry. Every year, this topic is examined in paper 1, paper 2, where it has long structured question, and paper 3, where students do it practically. It is a very important topic, and in my view, it is the easiest topic one can ever study. Interesting in that it carries out so much content that has to do with our daily life in day-to-day activity. It carries about all the clothes we wear, and even our cells are just but organic molecules. In this topic, we are going to study several substances which have several names. We are going to study alkanes, alkenes, and alkynes. So simply, these ones are just hydrocarbons. So in short, we are going to study about hydrocarbons, and in these hydrocarbons, we are going to study their structure. The structure has also something to do with giving them their names. We are also going to look at how they are prepared and their properties. For the properties, we have the physical properties and their chemical properties, and finally we shall look at their uses. To begin with, it is paramount that we go back to structure and bonding in form 2. It is the basis of understanding this topic, especially when you have to look at the covalent bonding. So in form 2, covalent bonding was explained to be a type of bonding that involves sharing of electrons. In this topic, all our compounds will have a covalent bond, and this covalent bond will exist between carbon and carbon, or carbon and hydrogen. So in form 2, we realized that carbon can form covalent bond with hydrogen, and in that case we all know that carbon has 6 electrons and hydrogen has 1 electron, and amongst these 6 of carbon, it gives us the electron configuration of 2:4, and hydrogen gives us the electron configuration of 1. So here in this bonding, we normally have the open structure where hydrogen donates 1 electron and carbon donates the other. So carbon can share 4 of its electrons, of its valence electrons, to become stable, and at the end they are going to form a structure that looks like this, whereby carbon will have 4 bonds each. So this is a rule in organic chemistry, that carbon must always have 4 bonds. Remember that for each bond that you see, it represents 2 electrons, meaning that this particular compound represented by this particular structure here has got 8 electrons, 8 of them, because we have said that each bond represents 2 electrons, and in this we have got 4 bonds. So 4 multiplied by 2, we get 8. We can see another example here, and in this case we have a weird or something that looks weird. And in this example of bonding, we have carbon which has bonded with another carbon. Carbon has the ability to form a bond with carbon, and that is called catenation. Or in short, you can say the ability of carbon to bond with another carbon is called catenation. So in terms of definition, you could easily say that catenation is the ability of atoms of the same element to form bonds with themselves. For example, in this case, our carbon has formed a bond with another carbon. Remember our rule. Our rule is that carbon must always have 4 bonds anytime we talk about organic chemistry, 4 of them. If you count this at this carbon, you are going to get 4 of them, and you count the bonds involved here, they are going to be 4. So that should always never be forgotten. So when carbon bonds with itself, it forms 2 kinds of substances, and most importantly, it can form a hydrocarbon from the word hydrogen. This one is a hydrocarbon, and a hydrocarbon is a compound made up of hydrogen and carbon only, bonded together. And these bonds must always be covalent bonds. Now, we also have other types of molecules called organic compounds. Organic compounds are compounds of carbon apart from carbonates, carbon 4 oxide, and hydrogen carbonates. We have compounds that have let's say proteins. Those are organic compounds, but they are not hydrocarbons, because hydrocarbons are only formed by hydrogen and carbon alone. So in this case, we have looked at a situation where carbon can be able to form a bond with another carbon. So here I've used a single bond, and as I said, each carbon atom must have 4 of them. So this is 1, I can add another one to make them 4. 1, 2, 3, 4. And on this side, it already has 1, I can add 3 others to make 4. So in this case, we said that we term this as catenation, a situation where carbon forms a bond with another carbon. So this ability is the basis of this topic. And because of this, that's why we have very large kind of molecules like a human being. A human being and animals and plants and all living things are made up of very complex organic compounds made up of so many carbons linked together. In this topic, we will go to specific kind of hydrocarbons. Remember, we said that a hydrocarbon is a compound made up of hydrogen and carbon bonded together covalently. So in high school, 5 hydrocarbons are studied. We normally have 3 hydrocarbons are studied, and 2 organic compounds are studied. So in Form 3, there are 3 of them. These are the hydrocarbons in Form 3. The remaining 2 are organic compounds, because they have oxygen bonded to them. For the ones which are studied in Form 3, they do not have oxygen, they're just simply hydrocarbons. So all these substances are organic compounds, but the first three are hydrocarbons alone. Now, in their classification, they normally have a certain way in which they begin and a certain way in which they end. You can see that all of them begin with the prefix ALK. All of them alk, alk, alk. But then they end with different suffixes. We have alkanes ending with the suffix ane. We have alkenes ending with the suffix ene. We have alkynes ending the suffix "-ine", and then we have alkanols ending with "-ol", and we have alkanoic acid ending with "-oic". Notice that these ones are the normal alcohols. Pombe, the ones we really love taking. Then alkanoic acids, they are also very common. For example, vinegar, it is one organic compound. So all of these are normally given one term, which we are going to see shortly. All of them are called, all of them are organic compounds, but only the first three are hydrocarbons. So we start with those that we called alkanes. And alkanes are called alkanes, and they are the simplest series. Normally, they are unsaturated. Unsaturated means that the bond between carbon and carbon is one, and they only consist of carbon and hydrogen. They have their specific names, and these specific names are normally derived from the number of carbon atoms. So remember, we said that there is a specific ways within which these hydrocarbons start and how they end. So for all the alkanes, the first member of this group of hydrocarbons start with this prefix meth, and therefore you get the entire name methane. The suffix is ane. For those that have two carbons, they have the suffix eth, and the name is ethane. The other member has the prefix prop, and the entire name is propane. The fourth member is butane. It has the prefix but, or bat, or how you'd like to pronounce it. There are so many of them. There are those that have 5 carbons, and those that have 5 carbons, it will be called pentane. 6, it will be hexane. Notice that all these words are derived from their Greek names. For pentane is pentagon, 6 hexagon, 7 heptane, heptagon, etc, etc, etc. Now, there's something I would like you to notice. The first member has 1 carbon and 4 hydrogen. 1 carbon is bonded to 4 hydrogens, making 4 bonds. For ethane, it has 2 carbons and 6 hydrogens. So the specific thing here is the difference between the first member and the second member is that the second member has a difference of 1 carbon and 2 hydrogen, meaning that if you add 1 carbon to the first member and you also add 2 hydrogens, you're going to form the second member. If you look at member number 3, our propane, it has 3 carbons and 8 hydrogens. If you subtract 1, you get 2 carbons. If you subtract 2 hydrogens, you get 6 hydrogen. So it means that the difference between the first member, methane, and the second member, ethane, is 1 hydrogen and 2, it's 1 carbon and 2 hydrogen. The difference between ethane and propane is again the same, 1 carbon and 2 hydrogen. Again, the difference between propane and butane is 1 carbon and 2 hydrogen. For this reason, these hydrocarbons, they differ from one member differs from the next by a specific number. This specific number is 1 carbon and 2 hydrogen, and therefore they are said to belong to the same homologous series. If we look at the example of our next members, you're going to notice that pentane has 5 carbons and 12 hydrogens. Then hexane has 6 hydrogen, meaning you add 1 carbon, and 14 hydrogens, meaning you add 2. So this is a specific way of coming up with your alkanes. You add 1 carbon, and 2 hydrogens so that you can get the next member. If you add 1 carbon and 2 hydrogens to octane, you are going to get nonane. If you add 1 carbon and 2 hydrogens to methane, you're going to get ethane. If you do the same to ethane, you get propane. If you do the same to propane, you get butane. So for that reason, as I have said, these organic molecules are said to belong to the same group of alkanes. In short, they belong to the same homologous series. So homologous series are just hydrocarbons or organic compounds whose members differ from the next by a specific number. This specific number, in the case of alkanes, it is 1 carbon and 2 hydrogens. And we can see all the examples. In secondary education, we are only supposed to learn the first 10. The first 10 beginning from methane to decane. And next time we are going to see on how to derive their names, beginning with the revision of what has been studied today.